My name is Morris Matza, and in this video I want to explain what GraphQL cost analysis is and why it's important. Imagine a small business which retrieves data from various backend databases, legacy systems, and third-party REST calls. If they had exposed this data externally with hundreds of REST endpoints, then they would have secured and governed each of the endpoints in a number of ways. Threat protection makes sure request data isn't too big and isn't requesting too much response data. Rate limiting governs how many transactions per second are allowed per consumer on an endpoint. Monetization of an endpoint charges an API consumer per transaction. Instead, this company uses GraphQL in front of their backend. This seamlessly combines all of their backend data sources, both in-house and third-party, into a single graph, and allows API consumers to access all of that data with flexible queries of the client's choosing, all with a single endpoint. This simplifies and optimizes the data traffic of future development on both the backend and the front end, but it gives us a big problem with securing and managing our new endpoint. That single endpoint is flexible enough to accept dramatically different kinds of transactions. Many transactions might use one REST call on the backend, while some other single transaction might on its own result in thousands of REST calls on the backend. This flexibility is at the heart of the advantages of GraphQL, but it breaks all of our prior management models. Threat protection is problematic since it's possible to make a single short query that's not deep, not wide, not long, and yet extremely expensive to run on the backend. Both rate limiting and monetization clearly can't be fair or reasonable while treating all of these transactions the same. What can we do? The only real solution to this problem is to not treat all GraphQL transactions the same, even when they all hit our single endpoint. Instead, we calculate the cost of each transaction. For small or inexpensive transactions, we let many through each second, and we don't charge much money for paid API plans. For large or expensive transactions, we only let a few through each second, and we charge API consumers more money. For out-of-control queries, we return an error. Many questions remain. Where, when, and how do we calculate the cost of a GraphQL transaction? But some form of cost analysis clearly restores our key security and governance features while maintaining the flexibility advantages of GraphQL APIs. Thanks for watching.